You control wing anti-ice from the flight deck by a single wing anti-ice switch on the forward overhead panel. The switch has an on and off position. There is no anti-ice protection for the outer slats or the leading edge flaps. The bleed air from the pneumatic manifold goes to most of the leading edge slats. The wing anti-ice valve open lights indicates the position of the wing anti-ice valve. The lights are extinguished when the valves are closed. Now turn on the wing anti-ice. The lights are illuminated bright when the valves are in transit or there is a disagreement between the valve and the switch position. The lights are dim when the valves are open. Let's first look at ground operations. You must use wing anti-ice during all ground operations when icing conditions exist or are expected. Now turn on the wing anti-ice. Make sure the valve open lights illuminate bright, then dim. On the ground, wing anti-ice prevents the formation of frost and ice accumulation on the leading edge slats. Warning: the use of wing anti-ice on the ground is intended to complement and not replace ground de-icing, anti-icing, and inspection procedures. The engine thrust setting and temperature in the winged duct can cause the wing anti-ice valves to open or close. Now advance the thrust levers. Both valves close when the thrust on either engine is more than the takeoff warning setting. Now retard the thrust levers. If thrust is reduced, the valves open. Both valves close if either temperature probe senses an over-temperature inside the wing duct. If both probes sense a cooler temperature, the valves open. The wing anti-ice switch moves to off at liftoff when the air-ground sensor changes to the air mode. In flight, duct temperature and engine thrust setting have no effect on the operation of the wing anti-ice valves. Now let's look at flight operations. There are two methods of operation for the wing anti-ice in flight. The primary method uses the anti-ice system as a de-icer. This method allows the ice to accumulate before you turn on the wing anti-ice. Now turn on the wing anti-ice and look at the wings. This method provides the cleanest airfoil surface and the least runback of ice formation on the wing. It also uses less fuel than the secondary method. The secondary method uses the wing anti-ice system continuously to prevent ice from forming. Use this method only during extended operations, such as holding patterns, in moderate or severe icing conditions. This method creates a possible runback of ice formation and uses more fuel. The wing anti-ice system is turned off when it is no longer necessary. Now turn off the wing anti-ice. Make sure the wing valve open lights extinguish. Caution: Do not operate engine or wing anti-ice when the total air temperature is above 10 degrees Celsius. Let's now look at a non-normal condition with the left wing valve. If the left valve open light remains illuminated bright when the wing anti-ice is turned on, the valve has remained in the closed position. Icing conditions should be avoided. If the light remains illuminated bright when the wing anti-ice is turned off, the valve has remained in the open position. Bleed air must be controlled with the isolation valve switch and the engine number 1 bleed switch.